Hello, this is our project, a chatbot based on stackOverflow, and our presentation will be in 5 parts. And the first part is about the motivation of our project. You can imagine when users are trying to find some answers to the specific question online, they usually get a lot of information, and it's difficult to find the best answer, especially for some new beginners. And our goal is to build a chatbot will help find the best matched question with the user input, and we will return the top-rated answer of that question. So next part is about the problem definition. The input is pretty simple. It's just the sentence from user input. And output is the top-rated answer of the best matched question according to the user input. And I think the problem is we need to implement approach to compute the similarity between your input text and the questions stored in our database. And in our project, we are going to use this dataset. It's the Stack Overflow dataset from Kaggle, and Stack Overflow is one of the most famous online community for programmers. And after data cleaning, we would mainly use these two tables. And next part is about the challenges. Firstly, according to our dataset, it's very difficult and expensive to label the data. So the dataset itself, it couldn't tell us which pair of questions are most similar. Therefore, a lot of supervised learning algorithms, they are not appropriate. So for example, with a label dataset, we could perform the LSTM algorithm. Here we use the Coral dataset from Kaggle. Or we could apply the word-to-vector algorithm and implemented a basic LSTM model, and the experimental accuracy is about 60%. It's not bad. According to the experiment, we would say the label data, they are suitable for a lot of supervised algorithms. But here we are given the unlabeled dataset, so it's challenging to develop an efficient model to detect the similarities. Next part is about the approaches we used in our project. The autoencoder is a type of the neural network and used to learn data in an unsupervised manner. And as for the infrastructure, in our project, our goal is to find the intermediate result, the function edge, to represent the data from input layer. To be specific, we implemented an autoencoder for compressing the user input sentence to a short vector and use that to compute the similarities between sentences. Once we found the most similar question in the database, the program would return the top-rated answer of that question. And here we want to point out the similarity of two vectors. They are measured in the following way. So the more similar the similarity score is more close to 1. And here is the implementation of the autoencoder. We're trying to build the autoencoder with the pre-built vocabulary dictionary and the input sentence to have the input layer. And with the input layer, we will train our model to get the compressed layer, which is marked in purple. The final part is about the results and the analysis. Firstly, we want to introduce the measurement of the performance of the autoencoder. Since we are not provided with the labeled data, so it's difficult to test on the user input. But we would use another way to analyze. It can be measured by the similarity score of the input layer, the original long vector, and the output layer, the vector after encoding and decoding. If these two vectors, they are quite similar, it means the intermediate vector, it can work as a good representative of the original vector. And next is about the testing results. We tested on the 20% of the full dataset, and the average similarity score is about 0.47. It's not bad. And we try to train our model on different data sizes and evaluate its performance and running time. Firstly, it's about the performance. The similarity score is pretty stable on the different data size. It's about 0.45. And about the running time, it's running very fast on the small sized data, no more than 1 minute. But on the whole dataset, it runs for almost 50 minutes.